We are NewGen Gas, and we are here to store energy for the future. This is the skyline of Singapore that we've all come to love. What if it goes completely blackout? Why, you ask? Because Singapore runs on natural gas, literally. More than 95% of the power generation companies use natural gas, with less than 2 weeks in storage. We are talking about energy resilience. The same thing happened with China last year. They could not meet their demands. As a result, the households had to suffer without natural gas supply. This article that you see is less than 1 week old, which outlines the plans of Russian gas companies to tackle this boom in the demand by making more LNG storage on islands. But there are problems associated with LNG, that is liquefied natural gas. It's the industrial benchmark currently, but the industry says that it's too capital cost intensive. Not just that, there are safety issues associated with handling of LNG. This case that you see happened in 2014 in Washington, where there was an explosion in the LNG facilities. It resulted into killing and injuring over 100 people. The problem is serious, but not just that, it's big. Natural gas is the fastest growing fossil fuel. Out of the consumption graph that you see here, 11% is the storage requirement. That makes the storage market of 9 billion per year. And not just that, it's growing. It's growing at 4% up to 2030. Now, for this serious and big problem, we present to you our solution, that is solidified natural gas, storing natural gas in the form of gas hydrates. And we are here to store green, to store long, and to store safe. To talk about the technology more, let's look at a video from our recent CNA coverage.
At his laboratory at the Center for Energy Research and Technology, Professor Linga and his team are working on a solid plan to store natural gas in a more stable form.
This is a simple laboratory apparatus in which we make gas hydrates. Hydrates are ice-like crystal material which is similar to the ice that we make in the freezer, but manifold volumes of gas are contained in it, making it an energy-dense material.
By trapping natural gas in these hydrates, each pellet can store 170 times its volume in natural gas.
In terms of storage, they are reliable, suited for long-term storage. Unlike the liquefied natural gas, which always has a boil-off associated to it at moderate storage conditions. Thus, for this effort, we are funded by Energy Markets Authority for developing technology to ensure the energy resilience and energy security for Singapore.
Now, based on this technology, we designed I'm sorry for that. Based on this technology, we designed a turnkey process to cater to the market needs, our SNG turnkey process. The most crucial part of this process is our innovative reactor, which takes in the natural gas and the forming solution to form these hydrates. The magic happens inside, and it can directly produce the hydrate pellets with the gas trapped inside. These pellets can then be used to store in the storage tank for as long as needed, and then can be melted just like ice to deliver the natural gas, and the forming solution can be recycled in the system. Now, the most important benefit of our technology is safe natural gas storage. We have demonstrated over 6 months of storage, and it's as safe as holding ice in your hands, literally. We have a superior process for forming these hydrates. We can form them better than anyone else, up to 20 degrees Celsius with more than 85% reaction yield. Together, it results into lower costs. We can store these hydrates at 0 degrees and 1 atmosphere. And the capital cost for the storage tank is less than 50% of a comparable size LNG tank. Now, let's talk about our business model. Over the past 3 months, we did extensive market research, and on the basis of that, we identified natural gas producers and industrial users and power plants as our primary customer segments. And we went out further and did the customer validation, and on the basis of that, we selected power generation companies as our go-to market. To these customers, we obtain the revenues by means of A, selling the turnkey process and getting the revenue, and B, providing annual servicing of our turnkey process and obtaining the servicing revenue. We do this by establishing key partnerships with EPC and engineering companies. Before we move further, let's look at our journey. It started in 2016 with the EMA grant of 1.8 million. Subsequently, 2 years went into doing extensive lab testing for different kinds of reactor designs and processes, optimizing the system, based on which last year we obtained the priority patent filing for the reactor design. Currently, we are in detailed talks with leading energy infrastructure companies for conducting pilot testing for the technology. We'll conduct till next year, on the basis of which we will have to work with EMA. We already have a working relationship with them to establish the safety guidelines and the benchmarks for the technology, being the pioneers in the market. Subsequently, 2021, we enter into the market with our Genco segment, and next year, we target the second market segment of NG producers. So based on these milestones, our financial projections are in line with it. The first 2 years, we do extensive pilot testing for the technology without generating revenues. Third year, we start selling, and also we break even. By the 5th year, our revenues scale up to 250 million with more than 130 million of operating profit. Now, why should you guys trust us with the numbers that I'm talking about? Well, I am the founder of NewGen Gas with 2 degrees in chemical engineering, including a PhD, and a GC in management of technology. We are backed by our consultants in the form of Dr. Hari that we saw in the video. He is the gas hydrate expert, and Mr. Meng with over 20 years of industry experience and business expertise. Also, we are backed by our technology advisors in the form of Professor Linga, who is the Dean's Chair Professor at NUS and the gas hydrate expert. Also, Professor Karimi, who is the process system integration expert. We are here to seek seed funding of 1 million, the breakdown of which is shown in the graph, and we'll be happy to discuss it further. Now with this, I would like to thank all of you for your time and attention. We are NewGen Gas, and we are here to store energy for the future. You can contact us via the provided channels. We'll be happy to take your requests. I would like to thank you all again.
Thank you very much, Vaninda. He's indeed an energy guy, a lot of energy coming out from him. Okay.
I had a few.
Thank you. So let's now open the floor for questions. Maybe I'll start with one.
Sure.
Okay, could you elaborate, Melinda, the cost saving in terms of your technologies versus the existing liquid nitrogen storage?
First of all, the existing liquefied natural gas storage is only for short term. Even in Singapore, they don't use it for long term because of the safety concerns. They let it be there for less than 1 to 2 weeks at maximum. But because it's stored in liquefied form at cryogenic conditions, it needs to have a lot of insulation and layerings. For us, the capital cost will be less than 50% of a comparable size LNG tank. So the cost savings are in terms of the capital cost, And we're talking about hundreds of millions of dollars here. I mean, even if it's a one-time cost, but the savings are significant. And also our boil-off issues. LNG has a lot of boil-off issues in which some of the heat goes in, it evaporates, and you need to condense it and put it back in. We have much less issues as compared to LNG.
Okay, thank you. Any other questions? Yes, gentlemen.
Hi. Yeah, because natural gas, you're talking about pure natural gas. That means you're talking about methane level of how many percent?
We are talking about methane of around 90 to 95%, 90, 92%.
So it's almost for pure
yeah,
methane and not other normal different percentage. Because natural gas, as it terms, has many different compositions.
Yeah, it's a varying composition, as you are rightly pointing out. So we have tested out for varying compositions as well, a mixture of methane, ethane, propane,
Yep.
in different concentrations, which are quite similar to the natural gas. So in our lab, we have tested out for pure methane systems, for mixtures of gases, and we can form the hydrates for a variety of them, resembling the natural gas.
So the extraction process and then the application. That means once it is being stored, and how is it being
Given out.
given out again?
Yeah.
I mean, LNG you actually you vaporize it, but
Yeah.
then in your case, how does this technology work?
In our case, it's like ice. If you keep the ice outside, it melts. So for us, if the hydrate temperature is increased from 0 degrees to room temperature, it will melt and release the natural gas. So the energy requirement for melting it is not significant because you just need room temperature water. And in fact, this water can be used to extract the cold energy. So in terms of taking out the gas again, you just need to melt them by bringing the temperature back to room temperature, and then the natural gas will be released.
Okay, thank you.
Sure.
Okay, any other questions? Yes.
I understood that the density is almost 170 times more when you store it. So why is the cost of storing only 50%? It should have been less than 1%.
I understand. It's a very good question. The 170 times that you noticed is compared to the standard natural gas condition. Liquefied natural gas as a technology also stores much more than the standard conditions. It stores as much as around 550 to 600 times more than standard conditions. So when we say it's less than 50% of LNG, it's because LNG also has a lot of advantage because it's completely liquefied. We, on the other hand, are trapping it inside water, which is also there and occupying some space. So although we don't have a space advantage over LNG, but the advantage lies in the storage conditions. We don't need to store at cryogenic conditions. Capital costs and operating costs both go down.
Okay. Any other questions? We have time for last questions.
My name is David from Accelerate. I would like to ask, you actually introduced a foaming solution.
Mm-hmm.
Would they actually introduce impurities?
Well, we have some additives that we use to enable this whole process. That's where the magic happens. And you're right, it will introduce some form of impurities, but not significant. And when I said that we have done the customer validation and selected the go-to market, that's on the basis of the contamination. Whatever the contaminants that we'll add into it in the ppm level, it's compatible with the downstream power generation companies. Because the contaminant that we'll add, it will just burn with the natural gas in the gas turbine. And that's on the basis of which we selected our go-to-market customers and have identified these. Otherwise, if we target pipelines or some other applications, then we might have to do some post-processing and might incur more cost. But we have considered that.
if you can store longer, the futures market for energy is very volatile. A longer storage time helps you to play the market and get cheaper gas all around, isn't it?
Well, yeah, that's true. I mean, I'm in the stage where there are a lot of benefits of the technology, and I have to pick a few to outline. The yearly variation that you say of fluctuation is around 50% from the peak to the low point. For sure, we can use for that application as well. And yeah, we try to.
Buy cheap, sell high. Very good.
Yeah.
Okay. Very well. Okay, that's all the time we have for NewGen Gas. Thank you, Melinda.
Thank you. Thank you, Jack, so much.